Good morning, dear students. Last time we have discussed about the reaction of metals and non-metals with oxygen and reaction of metals and non-metals with water. And with respect to these two reactions, we have also discussed about the reactivity series. Today we will be discussing the next chemical property of metals and non-metals, that is reaction of metals with dilute mineral acids. In class 7 we have already studied what are mineral acids and what are organic acids. So in today's topic we will be discussing about metals reaction with mineral acid. So if you remember the reactivity series, the topmost three metals, that is sodium, potassium and calcium, they are highly reactive. As they are highly reactive, when this sodium will react with hydrochloric acid, that means we will take a small piece of sodium and we will place it in a test tube containing hydrochloric acid, and this hydrochloric acid is dilute hydrochloric acid. Then it will produce sodium chloride. What it will produce? Sodium chloride. It is a salt and it will release hydrogen gas. Right? So, what we observe that this sodium, as it is highly reactive, it is able to displace this hydrogen from hydrochloric acid and it is producing bond with this chloride and it is producing sodium chloride and hydrogen became free or hydrogen gas is produced. Right? Similarly, you can see the another reaction. This is also, so potassium is also a highly reactive metal. So when potassium reacts with sulfuric acid, here I have changed the acid, instead of hydrochloric acid we have taken sulfuric acid. When potassium reacts with sulfuric acid, it produces potassium sulfate. What it produces? Potassium sulfate. It is another salt and again hydrogen gas will be released. Right? So, we are observing that the metals which are highly reactive, take for example sodium, potassium, or even if we will take calcium, the reaction will be same. It will be producing a salt of that chloride or sulfate and it will release hydrogen gas. Okay, now we will discuss about the moderately reactive metals or less reactive metals than sodium, potassium, that is magnesium. If we will allow this reaction, like we will take pieces of magnesium and put it in a test tube containing hydrochloric acid, again we are taking dilute hydrochloric acid. Then we will observe that the bubbles are coming out. These bubbles in the test tube, suppose this is the test tube and I have taken the piece of this magnesium and I have added hydrochloric acid, dilute hydrochloric acid. Then after few minutes we will observe the bubbles are coming. If you will collect this bubble by putting your thumb on at the mouth of the test tube, or you will close this test tube's mouth, then this gas will be collected in the test tube. Now I am saying that it is hydrogen gas, but we have to assure ourselves that the produced gas is hydrogen. So that is called as confirmatory test. So how we will perform this confirmatory test? We will take a burning matchstick near the mouth of the test tube and this burning matchstick will make and will remove this lid from the test tube and you will find that the hydrogen gas burns with a pop sound. It will give out pop sound. This is an indication that the produced gas is hydrogen gas. Children, hydrogen gas is colorless and odorless. So, in order to confirm that the produced gas is hydrogen, we need to go for this test. We will take a burning matchstick near the test tube and we will find that it will burn with a popping sound, and then after a few minutes the flame will extinguish. This is the case with the moderately reactive metals. Another moderately reactive metal is aluminium also. In aluminium also, when the aluminium will react with hydrochloric acid, that time also you will find it will produce the salt and it will release the hydrogen gas. If you compare the rate of reaction from case 1 to this, you will observe that the rate of reaction is decreasing. Why it is decreasing? Due to the reactivity rate. As we go down in the reactivity series, the reactivity of the metals is decreasing. So, the moderately reactive metal will react slowly with the acid. Another moderately reactive metal is zinc. Zinc will react with sulfuric acid. Again, same thing, we'll take a test tube and in that test tube we'll place the pieces of zinc and we'll pour sulfuric acid, dilute sulfuric acid, and then with the help of a thumb we will block the mouth of the test tube so that the gas cannot escape out. And then we'll take a burning matchstick and test it. Again we will find out that the produced gas is hydrogen gas, and the salt which is produced is zinc sulfate. What will be produced? Zinc sulfate. Children, you have to learn these names also. This is magnesium chloride, right? So, we can conclude from all this that metals react with acid to produce metal salt and hydrogen gas will be released. Now, let us find out what is the case with the less reactive metal or least reactive metal. Now, just now we have seen that the metals which are highly reactive, they react with acid vigorously and they produce hydrogen gas, or they release hydrogen gas. And then we have also discussed about moderately reactive metals such as aluminium or magnesium, zinc, etc. They also react with acid, dilute acid, and they do produce hydrogen gas. But the rate of reaction is comparatively slow compared to sodium and potassium. Now let us discuss about the examples of metals which are less reactive or least reactive, such as copper, mercury, silver, gold and platinum. Children, if you remember the reactivity series, these metals are placed below hydrogen. That means they are less reactive than hydrogen, and that is the reason that they are not able to displace hydrogen from any mineral acid. They are not able to displace this hydrogen from the mineral acid, so there will be no reaction. Why there will be no reaction? These metals, copper, mercury, silver, gold and platinum, they are less reactive or least reactive. We can say as we go down, they are considered as the least reactive. The least reactive one is platinum. So the reactivity is decreasing in this order. And as these are placed below hydrogen, you will find that they will not react with the mineral acid and they will not be able to displace hydrogen from the acid, and there will be no reaction. Understood? So, we have discussed about metals reaction with dilute mineral acid. Right? So we'll perform an experiment to understand this, how the gas is evolved and how we confirm that it is hydrogen gas. We'll be performing one small activity in the lab. These are the zinc granules. So I'll be taking 1 or 2 granules of zinc in a test tube, and then I will add the drops of, I need a small piece of this zinc granule. Then I will be adding dilute hydrochloric acid. With the help of a dropper, we'll be adding few drops of dilute hydrochloric acid. When I have added this hydrochloric acid, you can clearly see the bubble formation. Now the hydrogen gas bubbles are getting formed. Now we will be collecting these bubbles. I have blocked this mouth of the test tube with my thumb so that the gas will not escape. Now as you can see, this is colorless and odorless gas. Now we have to confirm that the produced gas is hydrogen gas. So how to confirm it? For that, you take the burning matchstick. Now you have observed the pop sound. So this pop sound indicates that the produced gas is of hydrogen gas. Clear? Seen the reaction of metals with acid, and we have found what are the products produced in that reaction. Now we will discuss about reaction of non-metal with acids. So what are the non-metals? Carbon, sulfur, phosphorus, etc. They are all non-metals. You already know the examples of non-metals. So these non-metals generally they do not react with acid, as they are not able to displace hydrogen from the acid. But if you will take sulfur powder and mix it with concentrated nitric acid, then you will observe that sulfur dioxide gas, nitrogen dioxide gas and water will be produced. So what we have changed, in the case of metals reaction with acid, we have taken dilute acid, if you remember. Now we have taken concentrated acid. Why we have taken concentrated acid? Because these non-metals, they are not able to react with dilute acid. So now if I will mix sulfur powder with nitric acid, concentrated nitric acid, I will obtain sulfur dioxide gas, nitrogen dioxide gas and water. Similarly, if I will mix carbon with nitric acid, concentrated nitric acid, then I will obtain carbon dioxide gas, nitrogen dioxide gas and water. So generally we can conclude that non-metals, they do not react with acid, as they are not able to displace hydrogen from the acid. Clear? So today we have learned about reaction of metals with acid and reaction of non-metals with acid, and we have discussed the difference between metals and non-metals. I hope you have understood this topic. If you have any doubt related to writing the chemical equation or understanding the products, etc., you can discuss with me in next class.